So welcome to the video lecture series on theory of computation. In today's video lecture, we will be learning about the way of converting an NFA with epsilon to DFA problem. And here a question has been given in the form of regular expression a plus b whole star a b b. That has to be get converted to an NFA with epsilon, and then subsequently it has to be converted to DFA. Now when we try to convert this a plus b whole star a b b as an NFA, so it takes a diagrammatical form like this. It takes a form like this. We have a set of states spanning from 1 to 11. Okay, and this first part is actually connected with a plus b whole star, and the remaining part, this from spanning from 8 to 11, is connected with ABB. Now the first step, what we have to do is we have to find the epsilon closure for the initial state. So what is the epsilon closure for initial state? So initial state is 1 here, so we will make epsilon closure of the initial state, it is called as 1. So now epsilon closure for 1 is 1, then it goes to 2. So 2 here, then it goes to 3, then it goes to 5, and finally it goes to 8 here. So we will write 8. Now we will name this set as set A. Okay, set A. Now the second step is we have to find the delta dash for A here. That means as soon as you find a new state called as A, we have to find the delta dash for A and B. So here we just make it as delta dash of A comma A, which is equivalent to epsilon closure delta of A is actually 1, 2, 3, 5 and 8 A. Okay. Now we can apply this A in all the states. Now what is the possibility where we can apply this A? Now A cannot be applied in 1 because 1 does not have an input called as A. Now 2 does not have an input called as A now. Okay. But when you go to 3 has an input called as A, it goes to 4. Okay. So it goes to 4. Now next is 5. 5 does not have an input here. 5 has an input called as B, but instead of A it has B now. Now when you go for 8 has an input called as A, it goes to 9. So we will get two states. When we apply A on 3, it goes to 4. When we apply A on 8, it goes to 9. So we will get two states. So we will just make epsilon closure of 4 union of epsilon closure of 9. Okay. Now we will find epsilon closure for 4. So 4 is 4, 7, 8, 2, 3 and 5. Okay, it goes to 2. So now we rewrite this. It goes to 2, 3, 5, 2, 3, 4, 5, 7 and 8. 7 and 8 union of. Now epsilon closure for 9. No, 9 don't have any epsilon closure here. So we will simply write it as 9. Okay. Now when we rewrite this, it becomes 2, 3, 4, 5, 7, 8 and 9. Now we will just name this state as B. Name the state as B now. Okay. I will go for the next one. So since for set A we have applied input A, now we have to apply B. So delta dash of A comma B, okay, which is equivalent to epsilon closure of delta of 1 comma 2 comma 3 comma 5 comma 8 comma B. Okay. Now again B cannot be applied in 1 because 1 does not have an input called as B, and 2 does not have an input called as B, and then 3 does not have an input called as B. But when you go for 5 has an input called as B. When B is applied in 5, it goes to 6. So we will get 6 as an output here, and 8 does not have an input called as B here. 8 does not have an input called as B, but it has only input called as A. Now when we apply 5B on 5, it goes to 6. So we get epsilon closure of 6. So epsilon closure for 6. So 6, 7, 8, then 7 to 2, 2 to 3, 5. Okay, the answer is 2, 3, 5, 6, 7 and 8. Okay. So this is called as state C. Okay, because this is actually have a stark difference from the previous states called as B. Okay. So in previous state we have 7 states. In this case we have only 6 states. So obviously that is different from the previous one. So this is called as C. Now we have two new states called as A and B, B and C. So we have to apply A and B on B and C now. Okay. So when we apply, we just go for this one. So delta dash of B comma A. So delta dash of B comma A, which is equivalent to epsilon closure delta of, now what is B here? B has states called as 2, 3, 4, 5, 7, 8 and 9. Okay. Now we have to apply input A. Now what is the possibility here? A cannot be applied on 2. A can be applied on 3. When it is applied on 3, it goes to 4. Okay. Now again, when it cannot be applied on 5, it cannot be applied on 7, it can be applied on 8. When it is applied on 8, it goes to, when it applied on 8, it goes to 9 here. Okay. So 9, no possibility. So 9 you cannot apply. So the answer is here is, we have only two possibilities, that is epsilon closure of 4 union of epsilon closure of 9. Okay. Now we have a similar output here. So earlier cases we have found epsilon closure for 4 and 9. So epsilon closure for 4 and 9, it is equivalent to B now. So there is no need to recompute it. We will again get the same answer. So now we just make it as B. Okay. Now we will go for the next one. So delta dash of B comma B. So delta dash of B comma B. So which is equivalent to epsilon closure delta of 2, 3, 4, 5, 7, 8 and 9 equal to B is equivalent to. So now see here, when we apply B here, B cannot be applied in 2, 3, 4, but it can be applied on 5. When you applied on 5 in the diagram, it goes to 6 now. Okay, it goes to 6. Now rest of the inputs we cannot apply. Now when B is applied on 7, it cannot be applied now. When B is applied on 8, it cannot be applied, but B can be applied on 9. When it is applied on 9, it goes to a state called as 10 now. It goes to a state called as 10. So we will get two states now. One is epsilon closure for 6. Okay, that is 6 you will get, and another state is 10 here. Okay. So epsilon closure of 6 union epsilon closure of 10. Okay. Now find the epsilon closure for 6. Epsilon closure for 6 is 6, 7, 8 and then go back to 3 and 5. So 2, 3, 5, 6, 7 and 8. Okay. So the answer is 2, 3, 5, 6, 7 and 8, and union of epsilon closure for 10 is 10 itself, because none of the epsilon closure is applied on 10. So now we get a state called as, when you merge it together, we get a state called as 2, 3, 5, 6, 7, 8 and 10. Okay. Now 10 is a new state. So this has not been repeated in the previous state. So now this is going to be a new state now. Now this is called as state number D. Okay. We will just name this as state D. Now B, we have applied two inputs now. The next is, we will go for C now. C we have to apply. So delta dash of C comma A, which is equivalent to epsilon closure of delta of, so what is C here? So C is 2, 3, 5, 6, 7 and 8. Now we apply A. Now when you apply A can be only applied in 3, it goes to 4, and A can be applied in 8 when it goes to 9 here. Okay. So now epsilon closure for 3 goes to epsilon closure of 4 and union of epsilon closure of 9. Okay. Epsilon quotient for 9 and epsilon quotient for 4 will be resulting me in the same answer. So we have already got it. So epsilon quotient for 4 and epsilon quotient for 9 is resulting me the answer called as B. So here also it results with an answer called as B. Okay. Now we have applied in C, we have applied A, we have to apply B now. Okay. So these things. Now we will go here. So now delta dash of C comma B is equal to epsilon closure delta of 2, 3, 5, then C is 2, 3, 5, 6, 7, 8. Okay. So 2, 3, 5, 6, 7, 8 is C. So 2, 3, 5, 6, 7 and 8. Now we apply B here. When we apply B, now listen carefully. Now when you apply B, only possibility is 5 will go to 6 now. Okay. And 6 you cannot apply, 7 you cannot apply, and 8 you cannot apply. So now epsilon closure of 6. Okay. So epsilon closure for 6, we have already got an answer here. So epsilon closure for 6 is C. So epsilon closure for 6 is C here. Okay. So now we just make this as epsilon closure for C. Okay. Now we have another new state called as D now. So now what is D? So delta dash of D comma A, which is equivalent to epsilon closure of delta of, now what is D? D has set of sets here. Now what are the D sets here? So D sets are here. Okay. So D is having 2, 3, 5, 6, 7, 8, 10. 2, 3, 5, 6, 7, 8, 10. Okay. So 2, 3, 5, 6, 7, 8 and 10. Now we will apply A here. Now what is the possibility here? A can be applied in 3, you are getting 4, and A can be applied in 8, you will be getting 9. So you will get an answer called as epsilon closure for 4 union of epsilon closure for 9. Okay, you will get the same answer called as epsilon closure for 4 and 9, you will get an answer called as B. Okay, now we will go for the next one. So delta dash of D comma B. Okay, because both inputs we have to apply. So epsilon closure of delta of 2, 3, 5, 6, 7, 8 and 10. So now so we have to find the delta dash of B here, D comma B. Now when you just take this B, we cannot apply in 2, 3, 5 you can apply. 5 means you will get an answer called as 6. So epsilon closure for 6. 6 you cannot apply. 7 you cannot apply. 8 you cannot apply. But when it is applied in 10, it goes to 11. So epsilon closure for 6 and epsilon closure for 11. Epsilon closure for 6 results in 2, 3, 5, 6, 7, 8. And epsilon closure for 11 will be resulting in 11 itself. Now merge it together. So you get a new state which includes 11. So we will name this as E now. Now delta dash of A comma B has to be applied for E also. So delta dash of E comma A. So that is epsilon closure delta of, now E is actually 2, 3, 5, 6, 7, 8 and 11. Now we apply A here. Okay. Now when you apply A, A can be applied in 3. and A can be applied on 8. So only percentage. Okay, A can be applied in 3. When it is applied in 3, it goes to 4, and when it is applied in 8, it goes to 9. So epsilon closure for 4 and 9. So we will get epsilon closure of 4 and union of epsilon closure of 9. So epsilon closure for 4 and 9 will be resulting me the answer called as B, which is already there. Okay. So now no new state is getting generated. Now delta dash of E comma B. So E comma B is epsilon closure delta of 2, 3, 5, 6, 7, 8, 11 and B. Okay. Now in this case, B can be applied only in 5. 5 means it goes for 6, and B cannot be applied in 11 here. Okay, 6, 7, 8 or 11 you cannot be applied. So when B is applied in 5, it goes to 6. So epsilon closure for 6. So only possibility is when it is applied in 5, it goes to 6. Epsilon closure for 6 is equivalent to C. Now there is no new state is getting generated. Now what we have to do is we have to just make a transition table. So transition table, there are 5 different states: A, B, C, D and E. Okay, there are 5 different states now. There are 2 inputs called as A and B now. Now we have to first construct a transition table. From that you have to construct a transition diagram. Okay. Now delta dash of A comma A. So delta dash of A comma A goes to B. Okay. And delta dash of A comma B goes to C. Now the first answer is B and C here. Okay. So in this table we will get B and C. Okay. Now delta dash of B comma A, delta dash of B comma B have to find. So delta dash of B comma A is resulting me, giving me the answer called as B, and B comma B is giving me the answer called as D. Okay. So B comma A gives me the answer called as B, and B comma B gives me the answer called as D. Okay. Now we will go for delta dash of C comma A. So delta dash of C comma A gives me the answer called as B, and delta dash of C comma B. C comma B gives me the answer called as C. So again B and C. So again we will write B and C. Okay. Now delta dash of D comma A. So delta dash of D comma A gives me B, and delta dash of D comma B gives me E. Okay. So delta dash of D comma A gives me B, and D comma B gives me E. And finally delta dash of E comma A gives me B, and delta dash of E comma B gives me C. So now finally we will write B and C. Now when you closely observe this, which is called as a final state. Okay, now we have 5 different states: A, B, C, D and E. In the original diagram, you can see here that 11 is called as a final state. Okay. Now the state which consists of this 11 will be the final state. So when you just closely check this, A does not have 11, and B does not have 11 here. C also does not have 11, and when you come here, D also does not have 11. But when you come for E is a state which consists of 11 here. So obviously E is called as a final state. So I make E as a final state. Now A is called as an initial state. Now we will construct this diagram into a DFA diagram. We will take this table as a reference and construct a DFA diagram for this specific transition table. Now when we take that, so we have 5 different states here. So A, so I have B, so I have C here, D, and I have E. So let us assume that E is called as a final state here. Now when A is called as an initial state, so A, when A is applied, it goes to B. Okay, A when B is applied, it goes to C. Now B, when A is applied, it goes to B itself, okay. And B, when B is applied, it goes to D, okay. And C, when A is applied, it goes to B. C, when A is applied, it goes to B. C, when B is applied, it goes to C itself. So self loop. Okay. Now D, when A is applied, it goes to B. Okay. D, when B is applied, it goes to E. So D, when B is applied, it goes to E. Now coming to the last state called as E. E, when A is applied, it goes to B. So when A is applied, it goes to B. And E, when B is applied, okay, it goes to C. So E, when B is applied, we just make a loop here, goes to C. So this is called as a DFA diagram for the specific NFA. Okay. So thanks for watching the video. Have a good day.